Hello, everyone. Welcome back. Today, we're going to talk about operations with complex numbers. So our goals and what do we mean by operations? What we mean by adding, subtracting, multiplying, dividing. So those are our goals, are be able to add and subtract complex numbers, be able to multiply and divide complex numbers. So first, let's talk about adding and subtracting. So if we think about adding and subtracting, remember complex numbers, numbers that involve an I. So I is not a variable, but we can almost treat it somebody's like a variable. So look over at the right, to the left, it says to add or subtract, combine like terms, meaning real parts with real parts and combine imaginary parts with imaginary parts. So think of it like terms. So once again, I is not a variable, but in some ways, in terms of adding, subtracting, it almost acts like one. Okay, so let's look at an example. So let's say we have 4 minus 2i, and we're going to add to that negative 3 plus 5i. Okay. Now, first off, you may see it written this way or not. Here, the parentheses are just used as grouping. If you look, we're not doing anything with the parentheses. Okay. We're not distributing anything except a positive 1. So I actually get rid of the parentheses. We write this as 4 minus 2i, then, or plus, but then plus a minus, or just as minus 3 plus 5i. And now we want to combine like terms. Okay, so it means combining the real parts, the parts without I. So 4 and negative 3 is a positive 1. Then combine the imaginary parts, the parts with I. So negative 2, and negative 2i and negative plus 5i leaves us with plus 3i. And that then is the result. This is what you get when you add these complex numbers. Okay, let's look at one more. Let's look at one more with subtraction. So let's say we have this example, negative 5 plus I, okay, then minus 4. Oops, put that in the wrong place. So then minus, then in parentheses, 4 plus 9i. Okay. Now here, since we're subtracting, now if you notice over here, we're not distributing anything. We can actually, the first one, we can actually just get rid of the parentheses. We have negative 5 plus 4i. But here, we want to distribute the negative 1. Okay. It's a negative. So distribute, multiply that by each part. And that just, remember, distributing a negative just changes your sign. So that's going to give us negative 4 minus 9i. Okay, after distributing. Then here, this works just like the previous one. Combine your like terms. So we combine the real parts, negative 5 and negative 4 is negative 9. And combine our imaginary parts, positive 4i and minus 9i leaves us with a negative 5i. And that's the result of subtraction. And also, one thing I also mentioned, whenever you add or subtract complex numbers, your result is still always a complex number. Well, since all numbers are complex numbers, it's still complex. Occasionally, if it's somehow you just happen to cancel out the i's, you might just have just a real number or strictly imaginary number, but they're all still complex. Okay, so that's the idea of adding, subtracting. Basically, is essentially combining like terms, combining real parts with real parts and imaginary parts with imaginary parts. Now, let's take a look at the next one, multiplying. Multiplying is a bit different. Let's go over here. So to multiply, as this says, to multiply, we use either distributive property or FOIL. If we have two binomials, FOIL is an option. And then once we have simplified expressions of I, and then combine like terms. So it still involves some things we just learned. Let's look at our first example to kind of explain better how this works. So number 1, let's say we have, let me get to my examples. Number 1, 2i times 1 minus 9i. Okay. In this case, this complex number has no real part, just an imaginary part, and this one has both. So what I want to do then is distribute. Okay. So we're going to have, if we do that, then we're going to have 2i times 1. So the first one. Then we have a minus 2i times 9i. Okay. Now here, and of course, 2i times 1 is just 2i. Then multiply these together, so it's going to be negative. And so here we can think of multiplying our coefficients, the imaginary parts together. So this will be 18, and then I times I is I squared. Now, what you want to remember, I say recall, I squared equals -1. And so this is going to be 2i minus 18 times -1. And then, of course, that's simply going to be 2i, then -18 times -1 is plus 18. And then finally, one thing, this is perfectly fine, but usually the real part, the part without the I, is written first. So it's not necessary. So, but this is our result here is 18 plus 2i. And also in simplifying complex numbers, you want to make sure that you have no powers of I except the first power, because as you've seen in a previous video I did, you can always simplify powers of I, so either just 1, -1, or some power of I to the first. Okay, let's take a look at another multiplication example. This time let's take a look at a couple of binomials. So 3 plus 2i times 9 minus 4i. Okay, now here I'm going to use FOIL, which is an option. You can always distribute. So if you want to distribute, multiply this binomial times 9, then minus this binomial times 4i. But here I'm going to FOIL. What FOIL means, the F stands for first. So multiply the first terms together. That's going to be 3 times 9, which is 27. O stands for outside or outer. Multiply the outside ones together. So 3 times -4i is -12i. I stands for inside or inner. Multiply the inside ones together. Plus 2i times a positive 9 is plus 18i. And then finally, L stands for last. Multiply the last ones together. 2i times -4i will be -8i squared. Now, at this point, we just want to simplify and combine like terms. Okay, so look at what we can combine. Now, I and I squared are not like terms, but these are the ones in the middle. So we have 27. Then if we combine our I terms, our imaginary terms, -12 and plus 18 is going to give us with plus 6i. And then, as we saw before, I squared is the same as -1. So we have 27 plus 6i, then plus 8. And then finally, we want to combine, I want to combine our like terms, combine the real parts. And so 27 plus 8, that's going to be 35. So our result is 35 plus 6i. So it's once again just a regular complex number, both real part and imaginary part. Now, I said you can also distribute. You can try that on your own to see if you get the same thing. You get these same terms just in a different order. So multiply this binomial, this imaginary number, complex number times 9, and minus that complex number times times 4i. Okay, let's take a look at one more. Written like this to make sure everyone understands. Let's say we have -2 minus I, and the whole thing is squared. Now, one thing would be tempting to just say this is this squared minus that squared, but unfortunately that's not true. Okay, this is not -2 squared minus I squared. If you do that, you're actually going to miss part of it. You're going to miss one of your terms. So we'll explain that. So what we want to do then, this is equal to, so remember squared, what that means just is x squared means x times x, since we write this twice. So this squared means that we have -2 minus I times another version of the same thing, -2 minus I. Okay. Now, we can either FOIL or distribute. This time I think I'll distribute just to show that works. Okay. So by distributing, what I mean is we're going to multiply this binomial, this complex number, times negative 2. So we have negative 2 times negative 2 minus I. And then this one, that same complex number times this. So we have minus I times negative 2 minus I. Okay. Then distribute again. So negative 2 times negative 2 is positive 4. Negative 2 times negative I is plus 2I. Here again, negative I times negative 2 is going to be plus 2I. And negative I times negative I is going to be plus I squared. Okay, so as you can see, FOIL can be a little bit quicker if you do it, but it works either way. So as we did before, let's combine our like terms. So we have 4. We combine our I terms. That's going to be plus 4I. And then remember that I squared is the same as negative 1. So combine that, then we have 3 minus 4I. Okay, so that's our result. And you hopefully will see if you've done this, this would actually just give you the 3 without the I terms. This would have been 4. This would have been positive. Actually, it might have been something different. It might actually been 5. But anyway, it would not be the same. Okay, you have to make sure that anytime you see squared or been cubed, then it would have been 3 versions of this itself multiplied together 3 times. Okay, so that's multiplication. So basically distribute or FOIL, and then simplify your i's, if you have I squared, and also combine your like terms. Okay, finally, let's talk about division. Now, division is a bit different. We need to spend a moment about that. I'm going to say dividing. Okay, so divide complex numbers, multiply the numerator and denominator, what's called the complex conjugate of the denominator. The complex conjugate of the complex number is the same as the original complex number, except the sign, and from the imaginary part, the middle sign is switched. Okay, for example, a complex number looks like this: a plus bi. This complex conjugate is written, a lot of times written to indicate this bar over it, and that's going to be exactly the same, except the middle sign is switched. So let's look at a couple examples of these to kind of get the feel for it. So here we have a complex number. We'll make a table. And over here, we're going to have its conjugate. Now, what if we have just a real number, say 3? Well, actually, its complex conjugate is also just 3. Since there's no imaginary part, there's no sign to change. Okay. Now, what if we have something like a 2 minus 3i? And the complex conjugate of that, then, we just switch the middle sign, is 2 plus 3i. Okay, exactly the same. And also, if we had 2 plus 3i was our original number, its complex conjugate would then be 2 minus 3i. So these are complex conjugates of each other. It's not just a one relationship, they're complex conjugates of each other. Okay, now let's take a look at another one. What if you had, say, negative 3 minus 7i? Okay, well, here, maybe wondering what about the first sign? It stays the same. The only thing it changes is the middle sign. Okay, so its complex conjugate would be negative 3 plus 7i. And in the same play, the complex conjugate of this would be that. Okay, so if you have a sign in front of your real part, that doesn't change. Only the sign in front of the imaginary part changes, if there is an imaginary part. Like the first one, if it's just a real number is its own complex conjugate. And then finally, let's look at one like this. What if you have like negative 3i? Okay, where there's no real part. Well, actually, the complex conjugate of this, once again, to switch that sign, you think this is being a 0 right here, is positive 3i. Because once again, we're changing the sign in front of the real part, or sorry, the imaginary part. We're just switching signs in front of the imaginary part. So that's still the case here. We think of our real part as being 0. Okay. That kind of gives you a feel for how complex conjugates work. Now we'll see why this works here in a moment. Let's take a look at some examples of division. Divide. So our directions here just be to divide. And our first one will be 3i divided by 4 minus 5i. Okay. Now, what we want to get out of this is what we want is just write this as just a complex number, a plus bi. And as we'll see, when we do this, go through this process, that will happen. Okay. Now, the complex conjugate of 4 minus 5i, which we can write as, let's get the notation. If you see the notation, it'll look like this. 4 minus 5i is going to be just 4 plus 5i, as we saw above. We're switching the sign in front of the imaginary part. Now what we're going to do is multiply the top and bottom by this. So if you think about working with fractions, this is a fraction, since we're dividing. Then what we do to the top, we have to do the bottom, because if we do this, 4 plus 5i over 4 plus 5i, okay? Since it's 4 plus 5i over itself, this fraction is the same as 1, so we're not changing the meaning, okay? If we only multiply the bottom by this, we'd actually change what this fraction means. All right, now, why do we do that? Well, as we'll see, doing this actually will get rid of the I in the denominator. So essentially now we kind of have two problems like we just did multiplication. And so we're going to have 3. Let me write this step right here. So we'll see it. So we're going to have 3i times, there's fractions multiply across, so 4 plus 5i. And then here, 4 minus 5i times 4 plus 5i. Okay. Now, so the first one, distribute like we did earlier. So we're going to 3i times 4 is going to be 12i. 3i times positive 5i is going to be plus 15i squared. Okay, that's my numerator. Now, this you can either FOIL out or distribute. I'm going to FOIL it. So we do the first terms. 4 times 4 is 16. Outer ones, 4 times plus 5i is plus 20i. Or then the inner ones, negative 5i times 4 is negative 20i. And then find the last one's negative 5i times positive 5i is negative 25i squared. Okay, take a look at that and make sure you're convinced of that. Now, next thing, so remember I squared is negative 1. We also want to combine our like terms. So my numerator then is going to be 12i plus 15 times negative 1. Down here we have 16. We can combine these, and actually we combine these, if you notice they go away. Okay, so we have plus 20i, then minus 20i. Okay, actually let me see. Let me get rid of that because I'm afraid that may cover up something. So I may just do it this way. So I'm going to cross it out, but you see in your mind that these cancel each other out. We have negative 25 times negative 1. And if you notice, even now, we have no more imaginary numbers, no more i's in the denominator, which is what we wanted. Okay, now continue to simplify. So at the top, we have 12i plus minus 15. And down here, we have 16 plus 25. Okay, then, so I'm going to just turn this around. So the real part first, negative 15, then plus 12i. Down here, we have 16 plus 25, which is 41. Okay, now the last thing we want to do is we want to write this as we said before, we want a plus bi. So we want to write it in complex form. We don't leave it like this, we want to separate it. So since we're adding here, subtracting, we can break this into two fractions. So we have negative 15 over 41 plus, and a couple ways you can write this. A lot of times it's written this way, with the I out to the side. Oops, 41. Okay. Or it can be written as, negative 15 times over 41 plus 12i over 41. That's also perfectly fine. But often it's written this way, kind of match it like this. So here, this is our real part, and what's in front of the I is our imaginary part. And also, we want to simplify if we can. In this case, we can't simplify anything with 41. Okay, so what happened is we divided. So we took a complex number written like this, and then we showed that by multiplying the numerator and denominator by the complex conjugate of the denominator, and what we have then, what we get is an equivalent number that's written in a plus bi form. Okay, let's look at one more. This time in the numerator, I have 2 plus 2i, and down here, I have 5 plus 3i. Okay, the same thing we want out of this is to write this in a plus bi form at the end. Okay, now, so the complex conjugate, I'm just going to abbreviate that, of 5 plus 3i, okay, and it can be written as notation as 5 plus 3i with a bar over it to indicate it is the conjugate, and that's just going to be a number where we switch the middle sign, so it will be 5 minus 3i. Okay, now multiply the top and bottom by that. So just rewrite this, 2 plus 2i over 5 plus 3i. And then multiply the top and bottom by 5 minus 3i. And once going to the top and bottom, the same thing because this is 1. So I'm not changing what this fraction means. Okay, now this is exactly what we did before. It just takes a bit longer. There's a little more to do. Everything works exactly the same way. Equal signs there. Okay, so I'm going to FOIL the numerator. So 2 times 5 is 10. The first one's outer one's 2 times negative 3i is negative 6i. Inner ones, plus 2i times 5 is plus 10i. Then the last one's plus 2i and minus 3i is negative 6i squared. Okay, now do the same thing down here. And so first terms, 5 times 5 is 25. Outer ones, 5 times negative 3i is minus 15i. The inner, plus 3i times 5 is plus 15i. And then finally, the last ones, 3i times negative 3i is negative 9i squared. Okay. Now, there's another relationship between these two here. If you know difference of squares, there's a difference of squares formula. So if you don't want to FOIL it, you can just follow the formula and actually do this a little bit faster. But if you don't know that, you can always just FOIL it out or distribute. Okay. Once again, before we combine our like terms and simplify the I squareds. And so up top, we have 10. We combine our i's. Negative 6i and plus 10i is plus 4i. Okay. Now, remember here that I squared equals negative 1. So I'm going to shorten this a bit. So negative 6 times negative 1, it will be plus 6. Okay. Once again, everyone see that. Then down here, same thing. We have 25. Once again, these will cancel out. It's exactly the same except for the signs. And so I have minus 9 times a negative 1. It's going to be plus 9. Okay, so we're almost there. Then, once again, combine our like terms in the numerator. So we have 16 plus 4i. And then down here, we have 25 plus 9. And that's going to be 34. Okay. And then once again, want to write as a plus bi. So separate this into real and imaginary parts. I have 16 over 34 plus 4 over 34 times I. And then finally, let's simplify since we can. Okay, we can take a 2 out of each. So 1634 have a 2 in common. So divide them both by 2. That will be 8 over 17. And same here, take a 2 out of both. That's going to be plus 2 over 17 times I. So this is my real part. And what's in front of the I is my imaginary part. Okay, let's take a look at what we learned. So we learned today how to add, subtract, multiply, and divide complex numbers. Learn the adding, subtracting. Basically, you're combining like terms. Multiplication involves either distributing or FOIL, either one, where you can. And also simplifying like terms. Remember that I squared is negative 1. And then when you divide, then you have to multiply the numerator and denominator by the complex conjugate of the denominator. Then one's going to do those same things to simplify. And all these you want to write in the form of a complex number as a plus bi. Thank you. Have a good day.